December 26th, 2004, early morning. You're standing on the shore of Yala National Park in the south of Sri Lanka. The air is warm, humid, heavy with salt and sun-baked earth. And all around you, something is happening that you don't yet understand. The elephants are leaving, not grazing, not wandering lazily, leaving, up, inland, away from the water. Birds rise from the lowlands and don't come back. Deer that were standing calmly at the water's edge a minute ago vanish into the forest. And the sea is still calm, perfectly calm. In 1 hour, a wave as tall as a 3-story building will reach this shore. When the water finally pulled back, more than 30,000 people had died along the coast of Sri Lanka. And the rangers of Yala, walking the park, searched for animal carcasses and found almost none. No dead elephants, no deer, almost nothing. Across that entire vast territory, a couple of buffalo. And this is where curiosity turns into something that sends a chill down your spine. Because one thought is hard to shake. They knew. They knew before we did. Here's the question I want you to hold in your head for this whole conversation. What we take for premonition, is it a real perception of the physical warning signs of a disaster? Signs we simply aren't able to notice? Or is it our own habit of seeing a pattern in hindsight once everything has already happened? I'll be honest with you right away. Science hasn't closed this question. But what it has already worked out is more interesting than any myth. Let's start with the solid ground. What struck Sri Lanka didn't begin off its shores. 900 miles away, off the coast of Sumatra, a stretch of the Earth's crust, hundreds of kilometers long, tore open. Magnitude 9.1. One of the most powerful earthquakes in recorded history. The energy in it, like tens of thousands of atomic bombs. And here's the key detail. Between the moment the seabed shuddered and the moment the wave reached the southern shore of Sri Lanka, more than 2 hours passed. More than 2 hours. The earth had already spoken, and the water was still on its way. The only question is, who knew how to listen to that earth? The person on the beach felt nothing. No tremor, no sound, no smell. For you, that morning, the world was utterly silent, and in that silence lies the whole mystery. But here's where it gets complicated, and I'm obliged to say this honestly, or everything else is worthless. The story of elephants running for the hills is a beautiful one, but when scientists looked into it seriously, the picture blurred. In those same areas, some elephants wore satellite collars. Researchers tracked their movements by GPS. And when they pulled that data for that morning, it turned out not one of the tagged elephants behaved as if it had sensed anything in advance. One female actually stayed within 100 meters of the beach when the wave came. She survived. But not because she ran an hour earlier. She was saved by tall sand dunes that absorbed the water. That's the skeptic's argument, and it's a fair one. Most stories about animals that knew are exactly that, stories, anecdotes. They were collected after the disaster, when survivors recalled the strange things. And human memory is a treacherous thing. It eagerly builds signs where we want to see them. Thousands of animals behaved completely normally, but nobody writes about that. What we remember are those 3 elephants that ran for the hills. The United States Geological Survey puts it dryly and bluntly. No reliable, reproducible link between animal behavior and earthquake prediction has been proven to date. So if I ended here, the honest answer would sound like this: a beautiful coincidence plus our love of patterns. But I'm not going to end here, because there's one case that's not so easy to break with that explanation. Italy, the town of L'Aquila in the mountains of Abruzzo, the year 2009. A few dozen kilometers from the town, beside a small lake, a British biologist named Rachel Grant from the Open University is at work. She's no sensation hunter. For 4 years, she's been studying a dull, narrow subject: how the lunar cycle affects the breeding of common toads. Every spring, the same thing. The toads come to the water, the males grab the females, spawning begins. Year after year, like clockwork. And here's what sets her case apart from eyewitness tales. Grant wasn't remembering after the fact. She was keeping records in real time, counting the toads every day. The numbers went into the table before anything had happened. And here's what happened. 5 days before the earthquake, 96% of the males suddenly abandoned the breeding site, at the height of mating season. It's as if the guests stood up and walked out of a wedding right before the toast. 3 days before the quake, the number of mating pairs dropped to 0. Just 0. They left, and they didn't come back until the last of the aftershocks had passed. On April 6th, the ground beneath L'Aquila was torn apart. Magnitude 6.3. More than 300 people died. Grant's observation point was 74 kilometers from the epicenter. Remember where the weight of this lies. It's not somebody saw the frogs acting nervous. It's a documented, counted, recorded in advance departure of animals days before the event. And now the central question shifts. What exactly did they pick up? Here we climb to the next step and move from biology to physics. Because the Earth doesn't stay silent before a major rupture. First, the seismic waves themselves. An earthquake produces not one blow, but several types of waves. The first to run are the so-called P waves, fast, about 6 kilometers per second. They're weak, you'd barely feel them. And behind them, slower, come the S waves, the ones that bring buildings down. The gap between them is seconds, sometimes tens of seconds. Modern early warning systems are built on exactly that gap. Catch the fast, harmless wave and shout before the destructive one arrives. Many animals, it seems, catch that first wave earlier and more finely than we do. But that buys seconds of warning, not days. And days are a different kind of physics. And this is where our main character appears. Infrasound. It's sound below the threshold of your hearing. You hear from roughly 20 hertz and up. Everything below that, to you, is silence. But that silence is full of events. Rock under strain before a rupture cracks, creaks, hums at frequencies your ear can't catch. The ocean, an incoming wave, shifts in the ground. All of it generates infrasound that travels for hundreds of kilometers. An elephant picks up sounds around 14 to 16 hertz and below, and communicates at those frequencies across many kilometers of savanna. Where there's dead silence for you, for it, there's a rumble. And there's a third step, the most disputed one. This is Grant's own hypothesis. She suggested her toads were reacting not to sound, but to chemistry. Before an earthquake, strained rock can squeeze out gases, radon, for example, and release charged particles. According to her data, this changes the chemistry of groundwater, and even coincided with disturbances in the ionosphere, the upper electrical layer of the atmosphere. A toad sits in the water with its skin. If the water has changed its composition, it knows that sooner than any instrument on the surface. Let me underline this. It's still only a hypothesis, not a proven fact. Look at how this ladder is built. The seconds of warning come from the seismic waves. The minutes and hours, possibly from infrasound and pressure changes. And the days, maybe from the chemistry of the earth. The higher the step, the less is proven, and the more interesting it gets. But come back with me for a moment to the toads. I want you to really see this scene. Picture a biologist who's walked to the same lake for 4 years. She knows these toads. She knows their routine better than you know the shape of your own week. Spring, mating season, the water boiling with life, and it should keep boiling for days and days more. And then she comes to the water, and it's empty. Not fewer toads, empty. The males who crawled here through fields and across roads, risking their lives for these few nights of the year, turned around and left. At the peak of the one thing that means anything to them at all. She stands at the empty lake and writes a number in her table, not yet knowing what that number means. 5 days later, she'll know. The ground beneath L'Aquila will rear up, and more than 300 people will be left under the rubble. And the toads, by that point, will have been sitting safe for a week. They hadn't read any seismic bulletins. No one had warned them. They simply sensed what our entire civilization, with all its instruments, failed to sense in time. And they quietly left. And here's what I've been leading you toward this whole time. We're used to thinking that we see the world, that our 5 senses show us reality, maybe not all of it, but honestly enough. The truth is that you live inside a narrow slit. You hear a tiny sliver of the sound spectrum. You see a thin band of light. Everything below 20 hertz, everything in the infrared, everything in the chemistry of groundwater and the trembling of the Earth's crust passes through you unnoticed, every second of your life. And the most honest thing science can say today is this: we don't know exactly what these animals are picking up, or how reliably. Grant's toads are one case, not a law. The Yala elephants are half myth, half sand dunes. No one has yet taught a toad to predict earthquakes on command. And that not knowing is not a verdict against the idea. It's an honest border, and science is standing at it. But even standing at that border, you can see the main thing. It's not about magic, not about a sixth sense out of cheap headlines. It's that reality is wider than your perception, literally, physically wider. And the animal next to you may be living, right now, in a fuller world of signals than you are. Not a smarter one, a wider one. The truth here is more interesting than any myth. The myth says they're magical. Science says something more unsettling. They're ordinary. They're just listening to what you're deaf to. So the next time your dog suddenly freezes in the middle of the room and stares at a wall where, for you, there's nothing but emptiness and silence, don't be so quick to decide there's nothing there. Maybe there's just nothing there for you.